Right. Thanks for this warm introduction, Kashish. And good to see a lot of participants today. Uh, should we wait for a couple of minutes, Kashish, or can we continue? Should we continue now?
Professor, we can get started. We don't want to lose out on the whole session. So for everybody who's here,
Okay.
I think we can already start and people will keep joining in.
Okay. And a couple of folks were asking whether the recorded sessions will be available for them. I think one attendee asked me. I
Yes,
think
Professor.
it
So
was.
this event is being live streamed on LinkedIn as well as it'll be available on YouTube for them. We will keep in touch with them and let them know where they can find the link.
Oh, yeah. Ambika was asking that. Great. All right, folks. So, warm welcome to you. And in this session, I would encourage all of you to be interactive, right? I will ask a lot of questions, and I would expect you guys to also ask me questions. And though we have a QA, we will not really have a QA session because the entire session is going to be Q&A. All right. So let's get started. Let me briefly introduce the agenda for today's session, and then we will go into a free-flowing mode. Hold on. Can you all see my screen?
Yes, Professor.
All right. So this is I'm having some chat. Okay. I'm having a question here in this class, what we're going to be present here. So Adisesha Reddy, this is what you can look into the agenda. Okay. So this is what we're going to be talking about today. What is ML? What is not ML? Understand how this relates to deep learning, data science, NLP, AI. Understand what kind of problems are not apt for ML, right? There are a lot of lectures which tell you what problems are apt for ML, but very few talk about where you should not use ML. And of course, I will also talk about what kind of problems are suitable for ML. And I will talk about some real case study done using ML and understand the cutting edge technologies today in terms of ChatGPT, diffusion models, Whisper, Dall E, LaMDA, Transformer, BERT, etc. And this is a flash news to all of you. And GPT-4. GPT-4 has been released today, and I started reading up on that. Very exciting. I can ask me questions later, maybe in a week, after I've read up more on GPT-4. Right? I have already signed up for as a user for that. I'm in the wait list. Right? So that's what we are going to be talking today. So any questions, folks? I think somebody raised a hand. There was somebody who had raised a hand. Was it Kashish? Anybody?
Yes, Professor, I've unmuted them. Magid
Huh.
Tema, I guess you can unmute and talk.
Hello, it's just thanks for this interesting session. It's just, if you don't mind, if you can make the slides in full screen, it will be more clear on the screen.
Sure, will do.
All right, thank you.
Thank you, Beckett.
All right. Any other questions? I think one more question has come from here. Open.
No, Professor, I don't think I see any questions. We can proceed.
Okay, very good. So let's get started, folks. Now, before I say anything, I want to ask you this question. What do you think is machine learning? Can anybody tell me that? What is machine learning? Give me your views, folks. What is machine learning? What is deep learning? What is that? Can anybody elaborate from your understanding? You can speak. It'll be better.
Folks,
Kashish,
please raise
all
your
are
hands
unmuted. If
and
they are unmuted, it'll be good.
Yeah, Professor. So they just have to raise their hand and I will be, giving them permission to talk. So all you have to do, folks, is raise your hand and you can share what is your thoughts about the question shared.
And folks, don't be afraid of being wrong. That's why you attended this class. If you knew all the answers, you may not have attended this class. Anybody? Okay.
We have a few in
George,
the chat
I
box.
got an answer. George says using code to process data and obtain new information. That would be difficult in another way. All right. I got
Pranjal wants
one.
to speak, Professor.
Yeah, Pranjal. Go ahead, Pranjal. You can speak?
Yes, sir. Sir, machine learning is the learning of machine.
To do what, Pranjal?
Sir, machine learning is the learning of machine.
Okay. And what is learning of machine?
Sir, all the operations and all the tasks which we do with the machine. All the needs which we fulfill with the machine.
Okay. All right. Lilith, can you elaborate? Machine learning statistical models to process data. Or Ambika? All of you are right in a sense. Okay, Matt, I'm looking at your answer using previous data trainer model and using it to predict outcomes. Very good. Anybody else who wants to go at what is machine learning? Guys can speak up, folks. It'll be easier. Fabio is saying machine learning is the use of computational power to use historical data to foresee something. Very good. Yeah, and request all participants to mention their full name rather than their nickname or first name or last name. That will be for everyone's benefit. Anybody else? Very good. Getting good response from all of you. All right, Abdul, I've got a very long answer from you. I'm going to read through that. Machine learning is a field of computer science and artificial intelligence that focuses on the development of algorithms, statistical models that enable computer systems learn and improve from experience without being explicitly programmed. Absolutely right. Sai Teja, a ChatGPT is an example to machine learning. Absolutely right. Anybody else? All right. Now let me give you the answer. I'm going to start my digital notepad. Just a minute, guys. Can you all see my whiteboard?
Yes, Professor.
It's machine learning. Machine learning there are three parts, right? It does three things. First, when when you give historic data with both inputs and outputs, it will figure out how the output is related to input. So it will learn. It will learn on output, prediction, when input is given. So once it learns that when any new input is given, it will tell the output. It will predict. It will predict the output. That's part one of machine learning. That means what it does is, when you have a data which has both the input values and output that you're trying to predict, so you give it past historical data containing both input and output. And machine learning learns how the output is related to input. And when you give it new input, it will predict the output. Let me give an example. Let us say that you want to predict apartment prices. Prices in, say, in city like Bangalore. I'm from Bangalore, so I'll give an example of Bangalore. And you have the inputs as square feet or square meter, doesn't matter. Number of bedrooms, number of balconies, locality, and these are called as inputs, and output is the price. So you have past data on the input and the output. Output is what we are interested in knowing, in predicting. So you have data like this. 1200 square feet, 2 bedroom, 2 balcony, Vidyaranyapura, and it costs 70 lakhs. That means 7 million. Price is in rupees, INR rupee. And you have something called, let's say, 2000 square feet, 3 bedroom, 3 balcony, let's say Jayanagar. Jayanagar, 4th block. Price is probably 2 crores, 200 lakhs, right? And so on. So you have data about all these, maybe about 10,000 rows. Then later, let's say you come up with one request. So question, then you ask a question for 1,500 square feet, 3 bedroom in 3 balcony in JP Nagar, phase 4, I think. What is the price? Right. So it will, that means this is the output. It will know that it will tell you what is the price of this apartment. It doesn't know the price. And it will figure it out. How does it figure it out? Using the training data. So we call this as training labeled data. Right. So you have past data. We call it labeled data because you have both input and the output. Once you know the input and the output, it finds out how the price is related to square feet, number of bedrooms, number of balconies, locality, and finds out some relationship. You don't have to tell it. It will find out. And once it finds a relationship, then when you give it new data, new apartment details and ask it the price, it will tell you that price. That is one part of machine learning. And incidentally, this part is called supervised machine learning. Supervised because you have the answer also. That's why it's called supervised. You have the questions, that is the raw data, and the answer. So from the raw data and the answer, it will know how raw data and answer are related. And when you give it just the raw data, it will tell you the answer. That is part one of machine learning. Any questions, folks? Is it clear? Thank you, Georgie. Or should I call you Georgie or Jorge? Sorry if I'm mispronouncing your name. All right. Now comes the second part. We clear up my face. Where I'm erasing my whiteboard. So what we studied before just now is called supervised machine learning. What we studied before is called as supervised machine learning. Second part is called unsupervised machine learning. So in supervised learning, X and Y are given and you find relation between X and Y. That is supervised. In unsupervised learning, only X are given. Only X is given. Your job is find patterns. Your job is to find patterns. I'll give you an example. Let's say, for example, right, we recently had the World Cup in Oman, right? World Cup football. And we had a lot of strong nations, Argentina, Brazil, Colombia, Germany, Spain, England, all many countries joining with very strong football pedigree. Before the World Cup started, if you want to predict who is going to win the World Cup, that's a machine learning problem. That comes under supervised machine. So you have past data of all the countries playing. And if you want to predict who's going to be the finalist, who's going to lift the World Cup, right? That is called supervised machine learning. Right? Now let's change the problem. If you want to predict why did one of my favorite football nation is Brazil, right? That's my favorite nation. And I was very disappointed when Brazil did not make it to the finals. I love all the countries, Brazil, France, Argentina, all of them. But Brazil is my favorite country. I was hoping that it could go on to win. But now, let us say, if I want to predict, if I want to find pattern, why did Brazil not make it? You're not worried about whether Brazil is going to win the World Cup. All right, Fabio. Thank you. If you want to predict whether Brazil is going to lift the World Cup before the match, you will say supervised machine learning. You're going to predict who's going to win. Now I want to find the answer. Why did Brazil not win? Why did Brazil not make it to the finals? That is unsupervised learning. We are looking for patterns. If you're trying to predict what or who, supervised. If you're trying to predict why or why not, unsupervised. So Jorge, in mathematics, solve some problems. Sometimes we contract a dual system. Can you elaborate more? Construct a dual system. Can you elaborate more? You can speak, Jorge.
Georgia, I can go ahead and unmute you. Kindly raise your hand. Just a second, I'm unmuting you. Yes, Georgia, you can go ahead and unmute yourself.
Thank you so much. I was
go ahead.
You have a series of equations and you can construct a dual system. You imagine in a simple mathematical model, polar equations and Cartesian or equations.
Correct. Correct.
You can construct that in machine learning.
Okay. So just wait for 10 minutes, Jorge. You can ask me this question after 10 minutes because I will tell you what this probably comes under the category what should be done and what should not be done by ML. Okay, if I forget to answer your question, ask me back in 10 minutes. Okay. So now this is unsupervised machine learning. So in unsupervised machine learning, we try to find out why or why not. Another example. For people joining from other countries, you would know that India loves football, but India is cricket crazy. So when India did not qualify for the semi-finals, did not make beyond the semi-finals in the World Cup, T20 World Cup in Australia, there was a lot of analysis done. So if you want to analyze why did India not win the semi-finals against England, why did it lose so badly? Right? That is an unsupervised learning. Correct. Now comes the third part of machine learning called reinforcement learning. Reinforcement learning is, yes, Lilith, go ahead.
Yeah, hi, sorry. So I just wanted to confirm, basically, unsupervised learning is when we are looking for a pattern in data. Is that what is considered unsupervised?
Yes.
Okay.
Yes.
Okay, thank you.
Very good. Very good. Yeah. So in reinforcement learning, it is like supervised learning, except that you don't get detailed feedback. You don't get granular feedback as what is the input, what is the output. What happens in reinforcement learning is the machine learns itself through a system of rewards. Right? It does some moves. If it reaches the good state, it gets a positive reward. If it does bad thing, it reaches a negative reward, penalty. It earns a penalty. If it does a bad thing, if it does a good thing, it earns reward. And the machine learning, the machine or the program, by automatically saying, I'll be greedy. I want to get as much positive rewards as possible, and I want to get as much negative, as less negative rewards penalty as possible. It learns the task. That's called reinforcement learning. All these three are part of machine learning. Right. And now coming back to slightly more deep dive into first two types of machine learning, which is supervised and unsupervised. In supervised learning, there are two types. Let me share my screen again. Can you all see my screen? In case you can't see my screen, folks, please do not hesitate to ask me to share my screen. Sometimes I forget to share my screen in the flow of the discussion. Supervised machine learning. If value you're predicting is numeric, it is called regression. We call it, so in there are advanced, there is more exact terminology for it. If the value of predicting is quantitative, I will not get into this because I covered this more in statistics class. If the value you're trying to predict is quantitative, it is called regression. If value you're predicting is categorical, it is called classification. Right. So in the example of World Cup winner held in Oman, will it be classification or regression? Can anybody tell me? It will be classification because we are trying to predict which country. Is it going to be Brazil? Is it going to be England, Argentina, Japan? Correct. So that is classification. If the value you're trying to predict is just a category, one of the possible values. Another example of this is predict what is the grade you will get. You have written an exam based upon your past performance and all that, right? Predict the grade. Will you get A grade, B grade, C grade, D grade, pass, fail, etc. Or could be just like pass or fail. That's a classification. Or given an image, is the image a potato or tomato? That's a classification. Regression is what is the price of an apartment? What is going to be the share price of, let's say, Ford? What will be the price of Ford stock when the stock market, maybe in Wall Street, opens tomorrow? What will be the price of Axis Blue Chip? Axis Blue Chip is no longer the popular fund, in my opinion. Let's say ICICI Prudential Tech Fund. What will be the price of ICICI Prudential Tech Fund, mutual fund in Sensex or Nifty? What will be the price when the stock market opens tomorrow? That is regression. So because in regression, you're looking at predicting a value which is continuous. Right? So that is what is machine learning. So I hope, folks, with this, you understand what is ML. All right. Now, this whole thing, well, let me tell you what is ML, DL, data science, NLP. Let me explain, dive into this. We have already covered machine learning. So let's understand data science. Can anybody tell me what is data science and what's the difference? Is data science same as machine learning? What's the difference between data science and machine learning? Anybody? Go ahead, please. Go ahead, Lilith.
Yes, so I'm just assuming since data science is all about analyzing, cleaning, structuring data, so it kind of precedes machine learning because machine learning is using, not always, but machine learning is using historical data.
Okay, all right. How about you? Data science, Praveen is saying analyzing the data. All right, go ahead, Margaret.
Okay. I think data
Am
science
I
is
pronouncing your name correctly, Margaret?
yeah, that's fine. Thank you. Thanks. I think data science is a broad term It can include statistical analysis, manipulating data, classification, machine learning, or finding relation between data. But when we come to the machine learning itself, it will be more specific on certain tasks within the field of data science.
Okay. All right. Very good. Very good answer. Both of you correct. Yes, Lily. Lily, sorry.
No, sorry, I think it was by mistake. I didn't have
Okay.
any.
Sure. Great. So now I won't go deep dive into data science because this is not a 3-hour class on machine learning. I'm talking overall about it. I'll give you brief. Data science involves a lot of things. Lilith was right, and so was the other gentleman. Right? So data science involves a lot of other things. So first you have to define the business problem. Then you have to get the data. Then you have to process the data. And when you process the data, you go through one very, very important step in any data science or any ML related project called exploratory data analysis. It's called EDA. You go through the EDA, understand the relationship between various fields, various columns, and you require good understanding of statistics to solve this problem, to understand the relations between the data, and you let statistics guide you into choosing the columns. And after you have done all that, then you decide, okay, how am I going to solve this problem? Am I going to use a simple relation, maybe Excel? Excel is also a good ML tool. Those of you who didn't know, Excel can be used for a lot of linear regression problems. Or should I write a complex algorithm? In that case, it's we use machine learning. So that's the difference between data science and machine learning. Machine learning is one process, one step in the whole data science, the top steps. Then comes deep learning. In machine learning, we can get one level of insights. It does not require as much data, but deep learning, we understand more deeper insights. We learn non-linear relations between various models. In fact, virtually almost all the cutting edge technologies, be it ChatGPT, be it Transformer, GPT 1, 2, 3, now 4, right? BERT, LaMDA, all those are based upon deep learning. And NLP stands for natural language processing. That involves processing text and getting some insights, both unsupervised as well as supervised. Right? For example, if I'm saying, hey, this movie is a very good watch. If you want to predict whether is the sentiment positive or negative, that is called. This we do using NLP. Or another example, I bought 100 kilograms of apple from this store and the price was so and so. So we want to quantify items. 100 kg is the amount, weight of items. Apple is the vegetable fruit I bought, name of the store. So this kind of thing is called name entity relationship, NER. That comes under NLP and deep learning. Another example of NLP is you convert one language, English to Spanish, or Spanish to English, English to Hindi, Hindi to English, English to Tamil, Tamil to English, right? This is called machine translation. Right? Or another example could be given a picture, transcribe the picture into words, right? Let's say you're going with your family to a beach and playing football there or volleyball there. You have a picture of you playing volleyball with your friends or family, and the caption would be generated as enjoying playing football with friends in the beach. All these are part of deep learning. Any questions? Kashisha, do you have to make any announcement now or you want to wait?
Yeah, Professor, we can make it now. I think now would be a good time. Just a second, Professor. I will share my screen. Are you able to see my screen, folks? Is it visible? Can anybody get?
Yeah, it's visible.
Yes,
It's visible.
yes, it's
Yeah,
visible,
thank you.
Kashish.
Thank you. Thank you so much. So yeah, well, in the beginning of the session, I had just announced that we do have something special for especially all of the attendees here. Before I go ahead and share what's there, I would just like to understand how many of you here are new and what backgrounds are you from. So just quickly go ahead and answer this poll if you can see it on the screen, and tell us a little bit about yourself. What kind of experience do you come from? And maybe after that, you can tell us a little bit about if you consider yourself as a data-driven decision maker. So if you can see the screen, I think you'll be getting a poll. Just take a minute, quick second to answer that. Great. This is just for us to understand how many of you are here so that, we can have a better approach throughout the session, as well as I think the announcement will make more sense to you that way. Awesome. I've got quite a lot of responses. A lot of them are here who have a lot of experience. That's wonderful to see. 10 to 15 years. We have quite a few. 5 to 10 years, less than 5 years.
Yeah, no problem.
Wonderful to see all people with less than 5 years experience as well, wanting to get into data and become a whole data-driven professional. Wonderful. All right, go ahead, please take the poll. I'll just wait for.
Yeah, please take the poll, respond to the poll, because there is a very good surprise that IPL has in place for you.
All right, thank you. Thank you so much. I see the rest of the attendees. Please go ahead and just quickly vote. Yes, thank you. Thank you so much. I hope you're able to see the poll. You can just click on the poll section if you're not able to see it. Thank you. Thank you so much, everyone. All right.
Sonupriya, very nice to see that. Class 12 students. Kudos, Sonupriya. Very nice to see a young student in the class. I wish you all the success, Sonupriya.
Wonderful. Folks, go ahead, take another question, and we'll go right into the surprise for you. A lot of us would like to consider ourselves as data-driven working professionals. We constantly are surrounded by data, we use data, but sometimes we might not end up using it in the right way, or the lack of knowledge or the right awareness would hold us back from making those decisions. So what do you think? Do you consider yourself as a right data-driven decision maker? It's okay to say that maybe you've not been taking enough decisions based on data and maybe you'd like to learn more, so you can go ahead and click that option as well. The third option says I simply go with my gut. A lot of us do that sometimes. But when it comes to our professional life, do we do that? It's okay if you want to go ahead and answer that as well. Not an issue. You can be honest here. No judgment at all. Good. Now, wonderful to see a lot of people making data-driven decisions already. A lot of people would like to learn about data-driven decision making. So wonderful. I hope this masterclass is helping you already. And I hope probably more and more masterclasses ahead will help you. Awesome. Thank you so much. All right. So what we have for you from the Institute of Product Leadership for all the attendees here is we have this amazing program in data science and business analytics. And that is what we would like to talk to you about today. That program is a way to upskill, is a way to know more, dive deep into data science. So we are offering a special scholarship. This is the IPL Special Grant Scholarship. For you to avail this program, this is currently priced at 1299, and this scholarship you can avail at just 699. And this is for all of those who just can't get enough, who this one masterclass is not enough and would like to dive deep and know more and understand more about how you can apply data science into the real world. You can go ahead and scan this QR code. To take this scholarship, you will have to give a small assessment. So that assessment will help you understand where you stand at. What are your gaps in your data knowledge and where you're already strong enough or you have enough awareness about. So like we mentioned, there's different layers of learning all the time. We keep mentioning that at IPL. So there are different stages of learning as well. So if you can go ahead and take that assessment, you would also get an understanding as where you stand and what are the gaps you would like to cover in your data knowledge. All I'm going to do is launch a poll. And if you're interested to avail this scholarship, you can go ahead and mark your answer. Another special announcement that I would like to make is we are trying to encourage as many women leaders in data as possible. We recently celebrated Women's Day, and we believe in celebrating Women's Day every day, trying to empower women in leadership roles, in high authority position levels, and encouraging women to get into data science and become data-driven decision makers. Hence, for women, this scholarship would be applicable at $599. We hope this empowers all of the women here who are watching this session to go ahead and try their hands on this course. If you still have confusions or if you want to know more about the course before you enroll, you can go ahead and select that option. Folks, I'm going to just launch a poll. And you can quickly answer if you would like to take the assessment, or maybe you would like to know more about it first. Maybe you would like to refer somebody you know who's interested in this course. Quickly answer and we'll go back to our learning session. We don't want to miss out on Professor Chandrasekhar's amazing insights. So we'll definitely go back in just about a minute. Go ahead, take the poll. If you're interested, click on yes, I would like to take the assessment. You can right now scan the QR code as well, and you can just save that link on your phone and keep it and then take the assessment. If not, then you can just go ahead and click on no, and maybe you can refer someone else you have in mind who's interested in data. Awesome. I see a lot of polls coming in. If you would like to know more about the course as well, you can get in touch with us and we'll give you a detailed breakdown at what it entails. Professor Chandrasekhar is one of the senior most faculty at IPL, and he takes many more classes like this. He dives deep into these subjects and elaborates much more in detail on how you can apply these in real life. All right, I'm just going to wait another jiffy before I go ahead and end the poll. And even if you'd not be very interested and you're just here for the learning, we appreciate that as well. We want to keep promoting learning and upskilling. So if this is your way to upskill, no problem at all. You can just go ahead and say no, and that's all right. Thank you so much, folks. I'll just keep it another second.
Sure.
Thank you. Thank you so much. Professor Chandrasekhar, over to you.
All right. Thank you. All right, folks. So now let's continue with our session. So far, we have covered the following agenda. Understand clearly what is ML and what is not ML. And we have not covered what is not ML. I will tell you that it's very short. Next, understand how this relates to deep learning and data science in NLP. Right? Now, let me just tell you, get into the question, what is not ML and what kind of problems can be solved by ML? So, for example, let me share my screen. Okay. Before I share my screen, let me first start with where you will not use ML. For example, if you want to predict what is the velocity of the body at any time, right? So velocity of the body, those coming from science background would know that velocity of the body is rate of change of displacement by rate of change of time. Right? So for a lot of problems, we have a mathematical equation. If we already have a mathematical equation, we don't need to use machine learning. For example, if you want to find out the differentiation of y equal to 2x cubed plus 3x squared. So dy by dx of 2x cubed plus 3x squared is 6x squared plus 6. So 6x. Let me share my screen. So if you say, let's say y x cubed plus 4x squared plus 3. If you want to find dy by dx, don't worry, those folks, those who are new to calculus or have not studied calculus, don't worry. This is not required per se, but I just gave it as an example. This is equal to 9x squared plus 8x. So to find dy by dx, no need for ML. If the mathematical relation is already known, you don't need ML for that. If you know how it is related, you don't need ML for that. Where do you need ML? Use ML. You have lot of data, say x1, x2, x3, lot of columns. These are all columns. And you know that they are impacting y. But you don't know how they are impacting y. There you use machine learning. If you already know the relationship between the variables, you don't. So, Jorge, I hope you asked me one question earlier. So I hope this answers your question. The area where will not be using machine learning. You can state your problem again if you want me to answer that. And this is a common misunderstanding, because if you know how the various fields X and Y relates to each other, we don't use machine learning. Because math is 100 times cheaper, many times cheaper, and you have certainty. Machine learning, you get approximate answers. You don't get the exact answers. And there are many cases where you can't afford to make a mistake. If you can't afford to make a mistake, don't use ML. Don't use ML as a primary algorithm. Have a human oversight. That is, say you have you want to make a diagnosis whether this person is having cancer or not. You use machine learning to come up with a preliminary diagnosis. Let the doctor examine that. Don't rely only on machine learning, because you can't afford to go wrong. If you are doing very mission critical applications and you're going to use ML to predict in many of those mission critical applications and you can't afford to go wrong, don't use machine learning. Machine learning is a field where you require data, many times a lot of data, not all the time, many times you require a lot of data. And based upon the data, you make some predictions or discover patterns. If you can't afford to go wrong, if you have to be 100% right, then ML is not the tool for you. There are other techniques. For example, theorem provers. Given a set of statements, prove the theorem. Those are all coming under artificial intelligence, not under machine learning. I will not cover that, though that's part of AI. Now let's talk about what we can do with machine learning. What are the machine learning applications? Right. One example is predict stock price will go up or not. predict which route to take to go to office in shortest time based upon traffic condition. 3, predict as a additional input to a doctor whether the person is likely to get cardiac arrest. In fact, many insurance companies use this knowledge to predict what is the likelihood of a person going to get hospitalized in the next 15 days. And if a person is likely to get hospitalized in the next 15 days, you give advance warning to that person. Better check out, are you guys okay? And things like that, so he can take a preventive decision. Because when a person is hospitalized, there's a lot of cost, health cost and financial cost to you as a patient, and also to the insurance companies because they have to pay the hospital bills. So whenever possible, can you avoid paying the hospital bills, and can you avoid getting admitted to hospital if you can take some steps. So this is a very big thing in US health, not only in US, all over the world. 4, evaluate insurance claim on a car accident based upon photo, based upon picture uploaded. Right. More examples. Predict NPA. NPA stands for non-performing asset. Let's say a company takes a loan from a bank and it is paying the EMI or premiums properly. But we can write ML to predict, is it going to be a non-performing asset? And this has become all the more popular, needed now, especially in light of recent information such as Silicon Valley Bank shutdown, Signature Bank's shutdown. Can we write an ML program to detect these shutdowns? Right. It's possible. It's complex, but it's possible. These are areas where we can use machine learning. I'll tell you some more use cases. Let me open my slide. More examples. Self-driving cars. All of you would have seen that, right? Self-driving cars. When you drive the car, automatically the program detects what are the objects in front of you. What is the type of that object? Is it a human being or pedestrian? Is it a bike? Is it a cycle? Is it a car? Is it a truck? Is it a school bus? Not only that, draw the regions of each of the object. That's called object detection. More use cases, chatbots. All of you would have heard of chatbot. So chatbot is an NLP application which intercepts all the questions that you ask and answers as though it's a human. Then you have machine translation, which is called language converter, English to French, English to Spanish, English to German, and vice versa. Right? I've already covered financial trading, NPA detector, facial recognition. This is by far one of the most common application of deep learning. When you walk into the airport, looking at your face, it will predict what is It will predict your name or your identity, and maybe it will also extract your whether you are an authorized person in the airport. Article summarizer. Article summary, given a big article, 1,000-word document, summarize it to maybe 5 sentences. Sentiment analysis. This class is interesting. This class is informative. These are all positive sentiment. The movie was too long. That's a negative sentiment. So these are all very, very important because many times a company launches an event. So when it launches an event or does a product launch, after the product launch, it scans the social media feeds, Instagram, LinkedIn, Facebook, Twitter, and based upon that, it finds out whether people are happy or not happy with that. That's sentiment analysis, right? Predictor of disease I already covered. Fraud detection, object detection I have covered that. Spam detection, given an email, is the email spam or not spam? And one of the most common applications of machine learning is recommendations, recommender system. When all of you would have bought from Amazon, Flipkart, or Walmart, or Netflix, Disney Hotstar, how do those work? So based upon if you like this movie, it automatically, if you say if you give a thumbs up to a movie, Netflix will know that you like these kind of movies, will give you more movies of this kind to you. If you buy a product in Amazon, based upon what you have purchased, product you have purchased will give you some recommendation. And also it will find out what is your taste compared to all other Amazon users' taste, and the users whose taste matches the most, whatever products those people perform or buy, they will recommend it to you. That is the recommendation engine. Video caption. These are all use cases of deep learning. Given a video, automatically caption them. Text to speech, speech to text, gender identification, age identification from image, living dead detection. These are all common examples of machine learning. Right. So, any questions, folks? I will let me pause to take any questions that you have. I think, did I answer your question? I think you asked me a question some time back. I think I forgot your name. Jorge. Is your question answered?
Awesome. Other attendees, if you have any questions, please raise your hand and I will unmute you.
Sure, Arvind. You can search for my. You can search for me in LinkedIn. CEO Native AI, Chandrasekhar Ramamurthy. You will get my this thing. And please mention you attended my master class, and I will happily accept your friendship request. All right, guys. Now, I would like you to wear a thinking cap now and tell me what you think. Give me an example of machine learning in your space. Can you guys give me an example of machine learning in your space, in your domain, based on what you have understood now? Go ahead. Thank you, Kashish. Actually, honestly, I don't remember my LinkedIn address. I always have to go to LinkedIn, find my address, and then paste it to you. Thanks for doing that.
Fabio, you can go ahead and unmute.
Yeah, go ahead, Fabio. Yeah, go ahead, Fabio. Yeah, correct. Alexa is the right answer. It's one of the examples of machine learning. Mary?
Fabio, have you connected to your audio? Because we're unable to hear you if you're saying something. You would have to unmute. Can you unmute and try again? Or try reconnecting your audio device that you're using. We're not able to hear you.
In the meantime, others, please think of a machine learning scenario in your based upon your limit, based upon your understanding now that you have acquired in this masterclass?
Fatma, we're still not able to hear you.
Not able to hear you.
You can try joining again and ask a question, or you can type your question in the chat box. If anybody else would like to ask a question, kindly raise your hand. Any and all sorts of questions are welcome. Please feel free to ask your questions without any hesitation.
Go ahead, Arvind.
Hi, sir. So I've been working on a concept since 3 to 4 months, and it's based on AI/ML. So what we are doing here is we have not started anything technical as of now. We are just doing a proper research. So what we are trying to do here is we are doing the KYCs from Aadhaar and PAN both together. Along with that, we are recently partnering with IRDAI so that we can find out all the insurances are there for all the people. And what we are trying to do here is we are trying to connect the holders with nominees.
Okay.
Okay. And with the help of connecting holders with nominees, we are also trying to map their family members so that we can find out if there are any unclaimed policies which have been left, which even the family members are not been informed.
Okay.
So is this possible? Because yeah, everyone says this is possible, but yeah, when we see the data and everything, it's pretty complicated.
So what is the typical data you have?
What we are getting right now is a sample data we have got. So we are getting the name of the person, policy name. Once we get the policy name or the policy number, we have to contact to authorized policy company. If it's from HDFC Life, then we'll have to contact them and get the data from them and bring it back to our database. And in that way, we'll have to do it for each and every policy numbers. And once we have that, yeah.
Very good question. This is a very good question, Arvind.
Yeah.
Now, so instead of asking the question, can I solve it in ML?
Sure.
One of the most important things you have to solve is framing the business problem. What is the business problem that you are trying to solve? So you don't know the business problem yet, right? So that is the most important. You have to find out what is the problem I'm solving. When you find out what is the problem I'm solving, then you go ahead and get the data, and from that get the data. So right now, you're in the first step. What is the business problem you are solving? Correct. So business problem you are solving cannot be as generic as I want to automate. Right? You want to say, if I have data, I want to predict what all insurance companies this person would have got, so that I can go to that insurance company and find out that. Once I go to the insurance company, there is no ML involved. I just have to ask a database lookup based upon this customer name or this Aadhaar card, whether you have any insurance. Right? Predicting what are the insurance policies this person might have gotten. That's second way is, you know this person's Aadhaar card. So if you know this person's Aadhaar card number, you have access, as because you are working for IRDA, in case you're working for IRDA, you will have access to all the life insurance companies, and you can just check each and every life insurance companies with the Aadhaar card, Aadhaar number. See any of the policies are insured. For this, you do not need ML. This is simply a REST API or web-based application or simple database lookup. Right? So therefore, you have to decide what is the problem you're trying to solve. And you will learn this in PGDSP. Because one of the most important is probably not given much importance to, that is the importance of business problem.
Okay.
Got it, Amit?
Yeah. So the problem is bigger, sir. What we are trying to do here is we are trying to chart unclaimed policies, which even people doesn't know. For example, if I am the holder, my grandfather has taken a policy and I don't know, even my father doesn't know about it. So what we are trying to do is with the names, we can get the Aadhaar link right now, Aadhaar data we can get, but the people, those who are not there with us.
Before
yeah.
Aadhaar.
Yeah, before Aadhaar, we cannot search for them like directly online as of now. But
okay. Sure.
but the database is there with IRDI and the companies, those who are like trying to digitize the data. Still, they are trying to digitize the old data. So what we are trying to do here is we are trying to map the family members which are old, like before the digitization. That is first thing. And then we are trying to come up with multiple questions like whether do you know this guy, or is he your grandfather, so that we can add them to their tree. And if we find any policies which are like recently converted from offline to online or digitized, we'll tell them that, okay, this policy is there, you can claim this policy and we'll support you to claim this policy, kind of thing.
Yeah, so this is this can a lot of elements. The entire thing cannot be done by ML. Lot of elements in this can be done using ML. Lot of individual, lot of tasks in this main task can be done by ML. And in order to solve this, you have to get deep dive into the problem, into the data, and then start with the problem framing, and then collect the data and then do this. For example, you can predict whether this person, let's say you have collection of all policies which have not been claimed. So from this, you can probably predict who, which Aadhaar, which current member can be likely be associated with this, using lot of details, using lot of demographic and locality address details.
Okay. So actually, we will not get exact data who have not been claimed. We will have to find it out. So that's
Yeah,
the
right. So
biggest
that
challenge. Yeah.
part, that part you can query the program. All insurance companies will have policy which are still in force or which have elapsed or something like that. You can
Yeah.
you can get that by writing a query. You don't need ML for that.
Okay. Okay.
Right. So
Okay.
yeah, so you can feel free to, we can discuss at a later point offline. If you require any help on this, we can discuss offline, or when you join the class, you can ask this question in the class also. I would be, we'll have more time to answer that question in detail. Okay. Anybody else, folks? Anybody else wants to talk about the use cases? All right. So if there are no other questions, let me continue further. Oh, go ahead, Fabio. Go ahead. Please ask your question, Fabio. Absolutely. This is an ideal case of ML, Fabio. We can use ML for this. Okay. But we have to get into more details. All right. Now let me go slightly deep dive into ML. So in machine learning, we talked about supervised machine learning, which is of two kinds: regression and classification. And we talked about unsupervised learning, which is detecting pattern. Yeah. And a lot of other things which I will not get into right now. There's another thing called principal component analysis. Then you have things called self-labeled data. These are the topics we'll cover in more deeper at a later stage. Then we have reinforcement learning. Now, in supervised learning, I told you, you need to give an input. You have to give an input and output. You learn the relation between input output, and then find out what is the relation, and using that relation predict when new input comes. So there are a lot of algorithms. These algorithms are K nearest neighbor, naive Bayes, decision tree, And family, by family, it includes random forest, data boost, XG boost, gradient boost, etc. A lot of other things. Then linear regression. These are most commonly used applications, ML algorithms. Linear regression, logistic regression, support vector machine, and then comes deep learning. Deep learning involves neural network, convolutional neural network, recurrent neural network, and family. By family, it means like one directional, bidirectional, deep, then LSTM, GRU, etc. Then we have attention plus RNN, transformer. That's the latest and greatest. That's what heralded a revolution in deep learning. And out of transformer is born BERT, Alberta, Roberta, Distilbert, T5, then LaMDA, then GPT 1, 2, 3, 3.5. 3.5 is ChatGPT is based on 3.5. Then GPT-4, which got released today. Right. GPT-4 has got 75% mark in a medical examination, but it got only 40 to 45% mark in calculus. That's a fun tidbit for GPT-4. And from GPT-4, we have other applications like Dall E. Right? That means given a word, it will give a picture. I will show you some examples of that. Whisper, a lot of other technologies. All these have been derived from deep learning. I specialize in these areas. These are my areas of interest. Not only this whole thing. Yeah. I work in these areas. Right. I do projects, consultancy in these areas. So this is the full gist about the deep learning applications. Now let me take you through some of the, go slightly deep dive into some of the deep learning applications. So I told you the new emerging technologies are transformer BERT. I already covered that. GPT-1, 2, 3, 3.5, 4.0. GPT-1 in transformer, you have those of you, how many of you have heard of transformer, folks? Anybody has worked with transformer or heard of transformer or GPT? Right. So transformer is one of the pivotal discoveries by Google and a few folks at Google. All right, Ambika. Transformer was first discovered in 2018, and then came BERT, and then came GPT, and other things. So transformer is typically encoder decoder based. So don't worry about it. Those are all advanced deep learning. If any of you are interested in deep learning, please contact IPL, or you can also reach out to me if you need any other help in deep learning. Right. Then you have BERT, then Whisper, LaMDA, diffusion models, Dall E, Dall E2, ChatGPT. So let's start with some of the applications. ChatGPT. ChatGPT derived from GPT-3 and GPT 3.5. And so it is similar to, there's one more large language model called Instruct GPT that was very good in understanding user questions. And one of the applications of GPT is you give it a high-level task. You give it a task and you ask it to write code for that task using Python. So that is called, it learned from Codex, right? So Copilot, Git Copilot. These are all applications of GPT. But ChatGPT has some issues. One of the major issues is called hallucination, artificial hallucination. So it gives plausible sounding answer, but it will be incorrect. There'll be a lot of factual mistakes. Okay. And another application is LaMDA, language model for dialogue applications by Google. It is built on Transformer, and it is able to give open-ended conversations like ChatGPT, but much lesser expensive, or much lesser compute power than ChatGPT. And the focus of LaMDA is to have open-ended conversation and make the conversation, the context should be meaningful and response should be specific. How are you? I'm fine. No, not like that. How are you doing? I'm actually suffering from headache. I mean, something example like that. Right? And it wants to avoid bias internalizing and mirroring and avoid hateful speech or giving misleading information. That's LaMDA 1 and LaMDA 2. Diffusion models are the latest one. They are called generative models. That means it creates text for you based upon what it has been trained before. Okay. And one of the best diffusion models is called Whisper, Dall E, Dall E2. They are all, both Dall E and Dall E2 has been developed by OpenAI, by Elon Musk and his team, and it is a GPT-3. It generates digital image from a textual prompt. For example, you can go to the openai.blog to get information upon Dall E, and you can use openai.com Dall E2. You generate digital image from text prompt. For example, I gave a text, dog playing cricket. It generated these images for me. Dog playing cricket. Whisper is an automatic speech recognition system trained on approximately 680,000 hours of recording. So this helps you in converting speech to text in multiple languages. Okay. So that's all I have for you folks. With this, I have completed what I wanted to cover in this masterclass. And I now open the floor for any questions. You can ask me any questions, and any other doubts you have, please do ask. Sure. Thank you, Jorge. Or Ambika.
Based on all of the insights shared today, if you have any questions in any of the specifics, please go ahead and unmute. We have one question from George, Professor. Can you teach us to apply this technology for business?
Absolutely. Margit, please talk to the panelist. Sure, Mohammed Admin, nice to meet you from Pakistan.
Georgia, I think we would definitely have another masterclass. That is a very deep topic to dive into. We can definitely have another masterclass. You can stay tuned. You can even request one. So we can get in touch with you, or you can get in touch with Professor Chandrasekhar over LinkedIn for the same.
Oh, we use ML in e-learning quite a lot, Mohammed. So, in fact, I have used ML in e-learning quite a lot. That's a very big topic, right? We can get into that in detail later. Thank you, Jorge.
Yes, the link will definitely be shared. You can find it on LinkedIn as well. If you can go ahead and visit our LinkedIn profile. Let me just go ahead and put it on the chat box for you. So you can find, also this is our website if you'd like to know more about the Institute of Product Leadership. And you can also check out the different kind of events we have. We do keep having these masterclasses, workshops, and webinars very often, folks. So you can go ahead and check it out. You can even stay connected with us on LinkedIn. Just a second, I will go ahead and share the link with you to stay connected with us on LinkedIn. You can definitely find all of the recordings here. You will also be able to find some of the recordings from our previous events, previous masterclasses, as well as sessions here. Professor, we have one question from Maitri. Can you please give examples of using ML in solving any social issues?
Yeah. I'll just, so ML can be used, for example, when you are walking in the street, right? And is it safe? Is it safe, etc.? Right? What is the likelihood? You can use ML for that. Or you can you think of any social issue? Can you ask me where you can use ML? I'll be able to answer that more specifically. Maitri.
Hello.
Yeah, go ahead, Margaret.
Okay. You know, Professor, during the COVID pandemic, lots of models and was dependent also in regression and the machine learning has been developed.
Yes.
But it didn't prove its efficiency. Correct?
Not really.
The sound is not clear. I cannot hear it.
Yeah, not really. I have been part of some
Sorry,
models where they use. Can you not hear? Am I audible to others?
No.
Pragya, am I audible? Kashish,
Professor,
am I audible?
We can hear you pretty clearly.
Yes, yes, Professor, you're audible.
Margaret, can you check your maybe check your headphone, Margaret? Yeah, Maitri, that's a good answer. Food shortage. Yeah, we can use machine learning to predict food shortage. What is going to be the grain output? Are we heading for another pandemic? Maitri. So Fabio, you asked a question, what is the best algo to start developing simple applications? So it's nothing like that. You will come into machine learning world that there is no answer is, you can't say this algorithm is best for this application. No, many times you don't know which algorithm will work. So you try multiple applications and see which one gives the best. This is what we call as hyperparameter tuning, hypermodel tuning. Fabio, does that answer your question? Okay. So, Margit, others are able to hear me, Margit? So you can look at the recording, Margit, right? And then you can refer to the recording. So the answer to the question is, machine learning was used in many cases where COVID predictions for COVID cases. We use different algorithms like gradient, XG boost, gradient boost to predict that likelihood of what is going to be the uh, uh, upper limit of COVID. But also, it's not necessary that you will get it right because it depends upon the data. It has to have different types of data. You will understand more of that when you come into the go through the section called exploratory data analysis. There you have to know what are the relevant fields, and based upon the relevant fields, decide how to use those relevant fields. Any other questions?
All right. Is there any other question that you would like to proceed with? If not, I will go ahead and share my screen with you guys again. We'll always be open to questions in case you would like to connect even post this session.
All right, guys, if there are no other questions, it was wonderful talking to you, and thanks for all the interactive sessions.
Thank you so much,
Yeah.
Professor. It was wonderful. I'm sure everyone here has had a great time with all of the insights that you've shared, especially how you've pretty much given a lot of real life examples. Helps a lot of people understand how they can actually apply it. Thank you so much for those wonderful insights. I hope all of the audiences have something to ponder upon, take notes, and keep coming back to. Folks, like I mentioned, we do have masterclasses and a lot of other upcoming events. You can visit the website that I put in the chat box. Before you go again, if you would like to take a moment to scan, I would also like to mention that the scholarship is only valid for the attendees of this masterclass, and it expires tonight. If you would like to register, please go ahead and just put it on the poll. I can just, have the poll again. And you can go ahead and give your answers if you would like to, or you can just drop me a message on the chat window here. If you'd like to scan, go ahead, scan it, and take this wonderful opportunity, I would say. Also, not to mention, the same QR code is for all of the women who are aspiring data leaders as well. The same QR code, you can just go ahead and scan it. You will receive a skill assessment. Now, again, just to elaborate a little bit on the skill assessment, this is for you to analyze your standpoint, your strengths, and your gaps in your knowledge and understanding of data. So even if probably you are not to take the scholarship, you can even go ahead and still take that assessment to see where you stand and see if you just qualify. So you will get an email from our team after you take the assessment to see if you qualify for this scholarship. Again, the scholarship will not be granted based on just marks or the score of that particular assessment. That assessment is simply to understand where you need to cover your gaps and what more you can acquire, where are the skills you can apply, and what new skills do you need to acquire to bridge that gap in your understanding of data. So your scholarship will not be based on that particular assessment, but that assessment will help you personally analyze your standpoint. And it'll also be applicable for you if in case you're looking for a career transition or an upskilling in the data science field, or if you're a leader in a decision-making position. I'm sure you will need data in every particular standpoint in your professional life. Go ahead and give you a minute again to scan this QR code. Not to mention, again, empowering all women, this scholarship is applicable for $599. This is in US dollars. And for everyone else, we would also love for you to try out this course. And if you want to know more, you can speak to our counselors. Again, on that same note, I would like to say thank you so much for being a part of this wonderful masterclass. Thank you so much, Professor Chandrasekhar, for, again, your wonderful insights. Do stay connected with us on LinkedIn.